Okay, for those that did not get all the way through the plate boundaries, we are going to discuss our assignments for plate boundary assignment. Plate boundaries, we're going to read our essential questions. What is the plate tectonics? What are three types of plate boundaries? What are the crustial features, also known as our landforms that form the plate boundaries? Okay. Right here on this particular thing, when you open it up, you're going to take and you're not going to save it as a Google Drive. You're going to save it. You're not going to save it as a Google slide. You're going to save it directly into your drive and then open it back up. Okay. When you are done with that, you're going to come over here and you're going to click on the buttons right here, and you're going to take and add a comment. Okay, it's showing differently on my screen, but you'll click your little buttons and it'll give you the opportunity to add a comment. Once you add a comment, you'll be able to click new and then add comment, and then it's going to ask you to select your page. You'll click on your page. From there, you're going to you're going to click on the area that you want to add comments to. You'll zoom real close into something, then you'll zoom it back out and click add comment, and then it'll open up and you can edit it from there. Okay. Now what we're doing here is we're going to list our 7 tectonic plates and our 7 minor plates. Okay. So our tectonic plates that we have will be based off of this little item here. Okay. So, tectonic plates, we have our major plates, which is North America, Eurasia, Pacific, and Antarctica, and African. Then all these smaller ones are our smaller plates. Plate boundaries. What is the engine that moves the plates? It's called convection current. So if you've heard of a current in a river, then you'll get an idea of what it does. This convection current moves all sorts of different ways. Okay, it moves left, it moves right, it moves up, it moves down. And because of the way it moves, the magma is circulated through the mantle, very much like a fire would be circulated through a house. Your hotter air is going to be higher and your cooler air is going to be lower. So your hotter air is at the top and your cooler air is at the bottom. And your hotter magma is at the top, cooler magma is at the bottom by your outer core. When these currents happen, it creates what's called slab pool. You have slab pool, and it brings the crust into what is called a trench. Now, keep in mind, when you hear the word trench, you're going to think underwater trench. Okay, if it's on the continent, then it's going to be a canyon. When you hear the word ridge, you're going to think underwater mountain. Okay? Now, keep in mind the differences between a continental crust and an oceanic crust. Okay? Continental crust has layers of rocks which form on the continents. Also forms show a shallow seabeds close to the shore. So even though you see all of this right here, not all of Australia is just dry land. Some of this part is underneath the water. It floats on top of the mantle, which is the ionosphere. As you can see right up here, this is the ionosphere, and it floats on top of it. Okay, the continental crust is older than the oceanic crust, and it's mostly made out of granite rock. It is thicker, but it is also less dense than the oceanic crust because it has to float on top of the mantle. Now, with the oceanic crust, you have a thin layer of crust that underlies in the ocean basins. Ocean basins is when you have um, the ocean floor without all the salt. Now, the ocean floor is made without all the water. The ocean floor is made out of basalt. It's very coarse. It's kind of like you taking regular table salt and sprinkling it on your food, only it's a lot more grainier and a lot more thicker than regular table salt. Okay, it's also younger than continental crust because of the fact that you have crust being created from magma and the seafloor is spreading. So therefore it has to be more dense than the continental crust though because it's responsible for carrying billions and billions of gallons of water. Now, as a direct result of that, what you're going to do here on this slide right here is you're going to take and you're going to compare continental crust to oceanic crust. So you're going to take and you're going to click on your edit. You're going to take and add a new comment. You're going to click on your continental crust page, and then you're going to zoom in and zoom it back out and add a new comment. You're going to add 3 comments that give me 3 details that are different, that make the continental crust different than the oceanic crust. And same for the oceanic crust. You're going to give me 3 facts that make the oceanic crust different from the continental crust. Now, this right here is based off of this. So as I read, you need to look at the convergent plate boundary, the transform boundary, and the divergent plate boundaries. Converge means to collide or come together. So what way do you think it is? Use your little arrows that you have to show that it is coming together right here. In what direction is it moving? Is it sliding side by side, coming apart, or going together? Now, I want you to list two tectonic plates that are coming together, and then give me an example of a landform that is a result of converging plates. Diverging means to be dividing or moving apart. So then you're going to take and you're going to show your arrows going in different directions here. Then you are going to tell me which way is divergent mean. Does it mean that it's sliding it by each other? Is it crashing into each other or moving away from each other? And then right here, you're going to tell me 2 plates that are moving away. You're going to tell me of a plate or 2 plates that are moving away from each other. Then you're going to give me an example of a landform right here. Okay? Now, when you have transforming, you're going to have sliding past each other. The plates are going to slide past each other. So right here, you can use an equal sign to show that it is sliding past each other. Which direction is the transforming plates moving? Is it moving away from each other, toward each other, or sliding past each other, side by side? Which one is it? Now, here you're going to take and you're going to describe your plate boundaries that are sliding side by side. So you need to find a place where you have frequent earthquakes in the United States and tell me what plates is involved in being responsible for making earthquakes. Then you're going to give me an example of where those earthquakes take place. Now, convergent plate boundaries. Now, I just want land to land, a boundary that is land to land, that makes a mountain. Then I want ocean to continent, ocean to land, that makes a volcano. And then I want an ocean to ocean that creates a trench. And all of these need to be examples of a convergent, divergent, or a transforming plate. Okay, so you're going to take and you're going to give me 2 plates that are converging that are under the ocean, 2 plates that are ocean to land that are diverging, or a ocean to ocean to ocean that is transforming, which means sliding past each other. It doesn't matter what order you use it in, but you want to use that. Here is a song that is done to the Addams Family. Okay, I'm going to butcher it for you. It is dun 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 dun. Converging is colliding, diverging is dividing, transforming is sliding. We are the plate boundaries. Dun 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 dun. That is the Addams Family tune. So this helps you understand what each one of these plate boundaries do. Divergent boundaries, dividing or moving apart, is when two oceanic crusts diverge and create a mid-ocean ridge, which are mountains under the ocean. I want you to think of ridges as underwater mountains. Anytime you hear ridge, you want to think automatically underwater mountain in this process. This process is called seafloor spreading. This is when new crust is created. And if you look right here, all these little pink dots here are mountain ranges that are underneath the ocean. Now, right over here is where we have the North American plate and the Eurasian plate crashing together. And as a direct result, because they are crashing together over an actual chunk of land, you'll see that you have a bunch of little volcanoes that form right along in here. Plate boundaries. Divergent boundaries are dividing or moving apart. Two continental crusts diverge and create a rift valley. This is when new crust is created. This example of the Great Rift Valley in Africa. Over millions of years, it will eventually fill in the valley, and we will have a new continent and a new ocean. For transform boundaries, this is when plates slip sideways. I want you to imagine that you have lines of pieces of paper going side to side on your hands. And if you were to take your hands and rub them together and smash them together really fast where you feel friction, then you will most likely end up with paper cut scars, right? Well, the same thing happens here. The crust is neither created or destroyed. There are many boundaries on the floor of this that are found in the seafloor. The most famous one is the San Andreas Fault in California. Now, right here, you can see where that fault is rubbed together, and it is created kind of like a scar, right? But it's a scar on the earth and not necessarily your hand. Okay, now there are different types, different ways that plates can converge or collide. You have continent to continent convergence. So put your fingertips right up against each other and push on them and keep pushing and pushing and pushing till your fingers go all the way up and your hands come together. That's what happens when the plates push up against each other. They form mountains, such as the Himalayas. Now you have continental ocean to ocean, which forms volcanoes, such as the Cascades in Oregon and Washington. The way that this is possible is the continent and the ocean and plates crash together. But they can't stay like that. And since the ocean floor is newer and then the continent and not as heavy as the continent, the ocean floor goes underneath the continent plate and it creates volcanoes. And that's what the Cascades are made out of, is a series of mountains and volcanoes. Now, the same rule applies to ocean plates. So let's say you have the Pacific plate and the Juan de Fuca plates pushing up against each other. Now, what happens is the older ocean goes underneath the newer ocean because it's more breakable, and it forms more mountains or volcanoes in this case, and they are responsible for creating the Hawaiian island chain along with the Aleutian Islands that are off the coast of Alaska. Converging boundaries. You have continental to continental boundaries. Two continental crests collide and push up against each other. This pressure causes both plates to rise, creating folding mountains. This is not a subduction zone. When you hear subduction zone, you want to think about a zone that the earth is either separated or losing more of its crust, such as a trench or such as a ocean to continental collision, converging boundary. And as you can see, right here is a perfect example of how the ocean goes underneath the continental crust because it's more dense, and the volcanoes began to form on the mainland of the continent. And a trench forms at the place where the plates collide. This is called a subduction zone because you have older crust being destroyed. The earth is losing crust or is separating a crust away from other crust. So as you can see right here, all of these wonderful little things here are all Cascade volcanoes. Converging boundary. You have ocean to ocean boundaries. When you have two oceanic crests, they collide and push up against each other. The older crest goes below the other one and creates a volcano arc of islands. This is a subduction zone because you lose crust because the two ocean crusts are crashing together. The older crust is going under the newer crust, and it creates all of these wonderful little volcanic islands. It's also responsible for creating the Hawaiian Islands. Now, because of COVID, we're not able to do this or this, but we will talk about the Ring of Fire. We have a long chain of volcanoes that surround the Pacific Ocean, one of the most geologically active areas of Earth. It's the site of frequent earthquakes and volcanic eruptions, and is caused by plate boundaries converging, diverging, and transforming all at the same time. So, right here, all of this is the Pacific Plate. Then, of course, you have the North American Plate and the South American Plate, and then you have the Nazca Plate down in this area, and then you have the Cocos Plate right over here, and then the Caribbean Plate right over here, and the Eurasian Plate here, then the Indo-Australian Plate is over here. So all of this area is surrounded by a bunch of plates that are pushing and pulling and moving and sliding all against the Pacific Plate. And this is why it is the most active place in the world for volcanoes, earthquakes, and other land forming opportunities. Now we're going to scroll all the way down to the bottom. Now that you have gone through with me, I want you to answer your essential questions. I want you to explain in your own words what you think plate tectonics are. I want you to tell me 3 types of boundaries, plate boundaries, and tell me which way they move. Okay, now right here it says relate plate boundaries to the formation of crustial features such as mountains, trenches, volcanoes, and ridges. So what they want you to do is they want you to list a pair of boundaries that form mountains, a pair of boundaries that form trenches, a pair of boundaries that form volcanoes and ridges. And for instance, you have the Indian Plate and the Eurasian Plate smushing together to create the Himalayas. So for this one, I would write Indian Plate, Eurasian Plate equals Himalayas. And you'll continue for trenches and volcanoes and ridges. Volcanoes and ridges may be done together. If you have any questions, please reach out to me through email or phone call or text.